Welcome everyone, and thank you for attending this evening's webinar. My name is Brad Costrachone and I'm the Sustainability Officer at South Gippsland Shire Council, and I'll be your MC for tonight's webinar. I start by acknowledging the Bunurong and the Gunai Kurnai peoples as the traditional owners and custodians of the lands and waters that I and many of you live and work on. I pay my respects to the elders past and present and Aboriginal elders of other communities who may be joining us tonight. If you're joining us from elsewhere in Victoria, I invite you to introduce yourself and acknowledge the country you're joining us from in the chat. Tonight's webinar, Designing for Resilience, is part of a series of webinars that Bass Coast and South Gippsland Shire Councils are running in partnership with Renew across 2024. Renew has been working in the sustainability space for over 40 years as an independent, not-for-profit body with a mission to inspire, enable, and advocate for people to live sustainably in their homes and communities. This webinar and all the webinars will be recorded and made available for future viewing on Bass Coast Shire's The CAP website, the Community Action Portal. The first six webinars in our Sustainable Living series covering the topics of solar, home batteries, all-electric homes, electric vehicles and winter comfort are now available to watch online if you missed those live events. We'll put a link to this in the chat. The 2024 Sustainable Living Series is designed to equip you with the information and knowledge to make your homes more comfortable, more energy efficient, cheaper to run, and more environmentally friendly to live in. Now, without further delay, I would like to welcome our expert presenter for tonight, Anthony Demarze. Anthony is from Demarze Architects and is a fellow of the Australian Institute of Architects with over 30 years experience specialising in residential and education projects. He's known for sustainable practices and contemporary design. Passionate about design's positive impact, he advocates for sustainability, responsible resource use and urban renewal. Anthony is a contributing member of the Australian Architects Declare movement since its inception. And in his spare time, Anthony enjoys helping his son enhance the energy efficiency of his Thornbury home. Welcome, and over to you, Anthony.
Thank you very much, Brad, and thank you very much for having me. So just by way of introduction, I'm here talking on behalf of Renew, before I open up the slides, who are a member-based organisation. They're not-for-profit, and their primary goal is to help transform Australian homes to be energy and climate resilient. It's something that I'm really pleased to be associated with Renew. I've been connected to them for some time and I've always really appreciated their support and what they do themselves within the the community, within the architectural and built environment community. A little bit just about myself. I am an architect. I've mainly my understanding of buildings, my understanding of energy efficiency is really through the experience that I have working in the field of architecture, designing buildings, building buildings, seeing how they perform, talking to people, talking to consultants, listening to what is happening on the ground. And much of the information that we know has been with us for a long time. So I don't think anything that I'll bring to the table tonight is new or novel in any shape or form. It's things that we all know, and it's something that we really need to tap into if we're going to make our buildings more resilient and responsive to the environment. So I'll share my slides and we'll get started. I will also say, I know there's a few of you here tonight. You are welcome to ask questions as I'm progressing through the slides. Perfectly happy to talk about any issues of interest and for it to be a little bit dynamic if that's what you so desire. So I'll just share my slides and do that. Now, hopefully that's all okay. I'm assuming so.
Yep, looks good.
Okay. So thank you for that little bit. Okay, so tonight's talk, we'll talk a little bit about resilience and why it's important. The fundamentals of passive solar design, resilience through retrofitting, resilience to extreme events, fire, floods, and storms, and some case studies that I've been involved with, and then some resources at the end of it. Again, I'll just reiterate, anything that you wish to raise, you're welcome to do so. It's important that you get the information that you want and you feel empowered to take on a journey of creating buildings that are responsive and resilient for yourselves. Resilience and our homes. I think it goes without say, I think anyone who's listening to the news or reading anything that's out there in the public domain is that our climate is changing, and even if it weren't, we have a requirement to create housing that is resilient to the climate. And the fact that the climate is becoming more extreme or is changing is just adding to that challenge. So when we talk about resilient housing, we want the housing to be adaptable to the people that it's serving, the people who are occupying those homes in places wherever they're living, whether it's in remote parts of Victoria, Central Australia, or in the inner cities of our urban centres like Melbourne and Sydney. They need to be affordable because financial stress really incurs a great deal of damage to people, to their well-being, and so forth. They need to be sustainable, and my view of what sustainable means is that it needs to have low impact on the environment. It should be a low energy building. It should use materials that can be renewed in some fashion. Locally appropriate. I can't stress the importance of buildings that are actually responsive to the climate, responsive to location. Healthy and secure. This is a big one because we know if we live in healthy homes that are connected to daylight, fresh air, clean water, our health benefits are much, much better. We're not paying money to go to hospitals to see doctors. We're actually living in a place which actually creates a healthy environment for us to live in. It's a financial asset. There's no question here in Australia that a lot of our capital goes into our houses. So feeling secure about our financial asset is particularly important. For it to be adaptable, our lives change when we're young and we have children. Our houses, become all things to all people. As we get older, there's less people in the house, but we still want that house to be comfortable and safe for the people who are occupying it. And, visitors, friends, people who have needs, someone who may lose a loved one, may need some temporary accommodation. So having buildings that can actually adapt to the changing circumstances is part of the resilient houses. Scalable, being able to meet the needs of houses. We seem to have a one-size-fits-all for housing in Australia, whereas, we need housing for single people, we need houses for large multi-generational families and everything in between. So the ability for houses to change and adapt is really, really critical. So resilient housing is a catch-all phrase, I suppose, that captures the idea that housing is there to serve our needs, that the housing is there so that we can feel safe and secure in the places that we live in. Healthy and comfortable. A lot of houses, and if you're reading in the sort of, daily press, the sort of things that are going on, talk a lot about houses that are actually comfortable and healthy for people, and that the health benefits of this is really critical. So there's a lot of toxic sort of materials that can get used in buildings, poor ventilation, which can potentially lead to mold and, sort of dank sort of interiors. These are places that can really contribute to respiratory problems, problems with our sense of self, our sense of, well-being. Durable, not needing excessive maintenance is really critical because, we all have lives to lead. And so if we're constantly having to do work in and around the house, we're not getting the opportunity to live our lives and, visit our friends. Energy efficient, if we're not stressing about how comfortable, how to make our building comfortable without needing the heating and cooling, that's really, really critical. And energy efficient houses are often very healthy houses because it's not relying on energy to heat and cool those houses. Low embodied carbon, so materials that don't require high energy use in order to be manufactured, things like aluminium, steel, but using timbers, naturally grown timbers, locally grown timbers are really important. And to draw on passive design techniques, which we'll talk a little bit about more, that they're affordable and resistant to extreme events. Again, I would suggest that many of you know all of this, and to some extent, I'm just stating the obvious, but I think there's value in that nonetheless. Fundamentals of passive solar design. I'm an architect who was trained in the 80s, mid to late 80s, and I trained at Melbourne University, and passive solar design is what I was taught as an architect. It emanates from a period of time when there was an oil crisis in the 70s, and architects and others were looking at how the design of buildings can respond to the changing patterns of seasons, be it winter and summer, to use cross ventilation, to use the natural sunlight from winter, where the sun is coming in at a shallower angle, and then omitting the sort of hot summer sun in the summer months. So it's very much about creating buildings that are responding to the natural environment. At the term passive is that it's essentially the design is doing all of the work, and it's allowing that natural occurring cycle of day and night and the changing seasonal conditions to essentially assist in the heating and cooling of the house. To some extent, all buildings are passive solar designed. It's just that if you get the principles of passive solar design right, then you are spending a lot less money on heating and cooling, and you're getting a house that's much more comfortable to live in. Passive solar design very much works with the local climate, so it's very much based on where you are located. So a house that's designed for far north Queensland is going to be very different to a house that's designed in the south of Tasmania and everything in between, because the conditions are different, the weather patterns are different, the climate is different. So we design knowing what the local climate can do. So tapping into local knowledge, tapping into buildings that already exist is a really key way that you can learn about passive solar design. And just as simple as going for a walk in your local neighbourhood and reflecting on the buildings that seem to work well, talking to neighbours, talking to people who are actually engaged in this sort of area of expertise will teach you an awful lot about passive solar design and what the local climate does. It's about maintaining a comfortable temperature within the house. Now, passive solar design won't necessarily deal with the extremes of weather, but it will deal with a large majority of the house, large majority of the year. And to some extent, even though we are moving into a more extreme climate, we still have many, many good days. You know, we still have beautiful springs. We still have, you know, warmish winters. We still have comfortable summers. So we take advantage of the majority of the time that exists within our environment, and we just simply cater for that through the design of the building. Primarily, it reduces the need for additional heating and cooling. So passive solar design is really embodied in that energy efficiency, because, as I say, it kind of came out of the energy crisis of the early 70s. So it's trying to design buildings that require less fossil fuels or less input of energy to keep it cool and warm, and relying on that natural cycle of day and night, day being where it's warmer, night being where it's cooler, and on the seasonal changes that occur between summer and winter. It can also be described as climate responsive design, energy efficiency design, environmentally sustainable design. There's probably other names out there as well, but essentially there's a lot of knowledge in this area. Architects have some knowledge, but local builders, local engineers, homeowners know an awful lot about this, and tapping into that body of knowledge is really, really valuable. The benefits, I think, are self-evident. Energy efficient houses, that is, that we require less energy from our gas companies, less energy from our water company, less energy from our power companies, less water coming into the house, because we're using the resources that already naturally occur within whatever block you're in. Health and well-being, I believe that's one of the biggest benefits of any good design, is that your health and well-being is improved as a result of good design, and good design that is connected to the natural environment. It can be affordable. I don't think it's of itself affordable, but I think it has the hallmarks of being affordable. And of course, it's sustainable, and sustainability is such a big factor in the way that we think about buildings in the 21st century. So we want our buildings not to add to the degradation of the natural environment. So by creating sustainable buildings, we're creating buildings that will last, and buildings that don't require as many resources from the natural environment for the people to be healthy and comfortable. The main principles is that it's designed for climate. So it is very much about the local economy, the local climate. Passive heating and cooling, and I'll just talk a little bit more about that, but it's essentially using the sunlight in winter to help heat your homes, and it's excluding that sun by having shading to the north, northeast, northwest faces of the building, so that there's less opportunity for buildings to overheat. Orientation is a really big part of it. We want to face our living rooms primarily to the north or northeast, so that we're capturing that really good light that's coming in from the northern side of the facade. We typically put bedrooms and bathrooms and things like that to the southern side, so we have those spaces which can afford to be a little bit cooler to the southern side. And we also want to get that cross ventilation occurring through the building, so that during those hot months, when there is a cool change, we can really capture the cool air that's coming in and through the building as the temperature changes. Thermal mass is when we're really using things like concrete or any sort of hard surfaces like brick to heat and store energy in winter, and also keep the house cool in the summer months as well. So it's a really important feature of passive solar design. Insulation, I think insulation is probably the most important thing, because if you can create, much like wearing a jumper or having that sort of coat around you, insulation has a massive benefit in being able to keep buildings warm during winter and help cool buildings during the summer months. Glazing has been really working. The advances in glazing, whether it's double glazing, triple glazing, and the coatings that you can get on glazing, and window systems themselves have greatly improved since I was a student. And yes, whilst they can be expensive, the benefits are there for a lifetime. So being able to get good glazing and good window systems is just so critical in passive solar design houses, and the benefits are really there. So when I was, a student, or when I was an architect, most buildings were single glazed, very leaky. So essentially we were living in tents, which, just the heat would go straight out the door. Shading is really critical. So having nice deep eaves, and some sort of screening, whether it's through plants or some sort of vertical shading through timber or aluminium. Getting the ventilation right, the air tightness. Preventing condensation is really critical on the inside of the building, because that potentially leads to mold. And really, we really have to think about how we're ventilating the space and the kind of footprints that we're creating so that we're not giving the opportunity for condensation to occur. Some of you may have heard of passive house. Passive house is different to passive solar design. There's lots of overlap, but they are two different standards when we're looking at the designs of dwellings in this kind of context. Design for climate. Well, if you look at how the construction code, the National Construction Code, which is essentially the building regulations which govern all buildings here in Australia, the NCC, it divides Australia up into, I think it's 6 or 8, climate zones. And you can see them on this image here. We in southern Victoria are essentially in a temperate zone. We're not in an alpine zone. We're in actually a very good climate zone because it doesn't get extremely hot, nor does it get extremely cold. And generally those shoulder months, the autumns and the springs, and much of winter and summer, we actually have a very comfortable climate where we actually, the climate sort of does all the work for us. But we do get cold and we do get hot, and we're designing buildings for those times where those things occur. You do need different passive design strategies for each of the climates. There's no question about that. So in a hot, dry climate, there's much more focus on cooling. In southern Tasmania, there's much more focus on heating the house. And all of these things, humans don't fundamentally change depending on where they're living within different parts of Australia. They may have different customs and different approaches, but more or less, we all enjoy a range of temperatures that we want our houses to be. So the design of the house is really being tailored, being designed in such a way that we can keep the people who are occupying those spaces at a range of temperatures, anywhere between sort of 22 and 28 degrees. And the sweet spot is around that 24 to 25 degree range. And we want to do that with as little heating and cooling as possible. So knowing your climate, and there are some really good architects and others who really understand the climate of their particular location. They know where the breezes come through. They know how the sun travels. They know the differences between summer and winter. They know all of that stuff really well. They know about indigenous planting, what grows, what doesn't grow, all those things. And while we can give general principles, having that intimate knowledge of what's happening in your particular location is really, really valuable. So the essentials, this is really the most basic things that you need to know. We want to orient our buildings towards the north in terms of the main living areas, because we, as humans, generally speaking, not all humans, but generally speaking, humans are attracted to light. We're attracted to sunlight. We generally feel more comfortable and we feel more alive. We're sort of naturally drawn to brighter objects, and we enjoy the heat of the sun on our shoulders. So if we can create buildings that actually let the sunlight in, particularly in winter, then that's a really good thing. And what happens in winter is the sun is at a lower angle because of the way the earth is tilted. And that means that the sun has the opportunity of penetrating much more deeply into our houses, which gives us the opportunity of bringing winter light, winter sunlight into our houses and creating that really nice warm effect. It can heat the slab or brickwork on the inside of our buildings. And that means that can store that energy and re-radiate that energy at night. And that's what we're talking about when we're talking about thermal mass. Now, generally speaking, in winter, the sun has less power to it, shall we say. So that even though we're getting the sun coming in quite deeply, the temperature is generally lower. But so having that sun come into our house is actually quite a good thing. In summer, obviously temperatures are hotter, 40, 45 degrees. So we want to exclude that sun. And the simple thing of putting in an eave overhang means I think the sun's at about 78 degrees versus 28 degrees in winter. So in summer, just by having a 600 millimeter wide, 2 feet wide eave, we can exclude a lot of that sun coming into the building. So typically we want to organize our buildings in such a way that it captures that naturally occurring phenomenon, which is that the sun rises in the east and sets in the west. And for a large part of the day, it's in the northern hemisphere. It's in the northern side of our building. So you can do an awful lot of modeling. So this is a project that we worked on where, you can actually start to look at the way in which the sun moves around the building and the effect that it has on the interior. So just by understanding the physics of the sun, the movement of the sun, and there are plenty of charts and computer simulations and, architects and draftspeople in your local area will be attuned to this, but also simple observation will give you a really good understanding of just the patterns in which the sun moves. I'd also say that not all houses can be oriented to the north. It depends on where you are located, and there are often constraints that don't allow you to have the perfect setup. That doesn't mean you can't apply passive solar principles to your house. Passive solar design is really understanding the physics of how the sun, wind, rain works and adapting your particular set of circumstances to meet those requirements. So I can give you some general guidance, but the rubber will really hit the road when you're in your local area, at your particular site, and really adapting the design of your building to the way in which those features work on your particular site. Passive cooling, much like passive solar, is about reducing heat gain. And I think increasingly, even in Victoria, I think, and in my time as an architect, I think a lot more emphasis is now being placed on the cooling of buildings. Whether that's because we're getting hotter summers or whether the expectations are that we have cooler environments, I don't know. But it has been something that I've observed, is that we are putting a lot more emphasis on cooling environments as much as we used to consider heating. As a rough rule of thumb, we would say that you would put 2/3 of your energy into heating a house and about 1/3 of your energy into cooling. Maybe that proportion is changing, but essentially we want to try and exclude the heat from the hot part of the day and be able to open up the building as much as possible when we're at night and it naturally cools down, and when there is a cool change and there are some cool breezes. So cross ventilation by opening doors and windows on opposite sides of the building, by having fans, by having different techniques, you can actually really very quickly cool down a house if you've got those openings working in your favor. Again, it's a good way of reducing energy bills, and it's a good way of opening up, as this image shows, a good way of opening up the building to the outside. So orientation, I think we touched on that a little bit before. Each orientation, so you could consider a building as having 4 sides, north, east, west, and south. But more than that, it's probably got 8 sides. It's north, northeast, north, east, southeast, south, and so on and so forth. Each of those orientations have a slightly different impact on the building in terms of the way the sun comes in and where the breezes come in. And in really simple terms, if you can design a building that understands those orientations, you'll go a long way to creating a passive solar design building. As I said earlier, depending on where your building is located, now, if you're in a suburban street and the street faces a particular direction and the backyard faces another direction, it may not be that you can put your living room to the north. There may be some restriction on that for whatever reason. That doesn't discount the importance of passive solar design. It's that you are being responsive to those conditions and adapting to suit that. But the primary idea is that we want to orient the main living rooms to the north, particularly the northeast, because we want to get that morning light into the main living rooms. And typically we want to exclude that hot western sun, particularly in late summer when the sun is very low but very, very harsh. And that can particularly lead to houses being very, very uncomfortable. The western facade of buildings is quite hard to shade because, as I say, the sun is coming in at such a low angle that you can't really have an eave overhang deep enough to exclude that sunlight. So in some fashion, you need to have either a vertical screen or some form of deciduous planting to be able to exclude that hot western sun. Shading. I love the image on the right. I mean, this is, excuse me, the use of a veranda, the use of a vine. These are the sorts of things that, anything that basically stops light, and light is not difficult to stop because, essentially once it hits a solid surface, it doesn't go much further. It can heat that object, that is true, but essentially we were trying to stop the heat entering into the main building during summer. So vines, shrubs, that natural aspect of the building is a really good way to create a healthy home. Now, if you look at the suburbs of Melbourne, we're getting bigger houses and smaller allotments, which means it's actually harder to put those naturally occurring elements like trees and vines and plants and things like that. So I would suggest that a big part of passive solar design is actually having a smaller footprint, not a larger footprint, so that you have the opportunity to have a larger garden and allow the garden to thrive around your building, which will create a naturally cooler environment for the people who are occupying that space. It's also a really good way to create connection between inside and outside. So the size of the dwelling, I think, matters a lot. And here in Australia, we have amongst the biggest houses anywhere on the planet, bigger than the US per capita. It's something like the average house here in Australia is something like 250 square meters, which is, quite substantial. And I've seen many houses that are much, much bigger than that. Insulation. Well, insulation is, I think, the thing that is so critical in a well-designed passive solar and climate resilient house. So insulation is, in very simple terms, a bulk product. It's wool fiberglass. It exists in the cavity of buildings, like in the roof space, in the floor, in the walls. There are different types of insulation. There's the bulk, there's the reflective type, and there's polystyrene. And essentially, it's creating a barrier between the inside and the outside. So it's essentially allowing the heat, let's say in winter, if you're heating your internal environment, it's enabling that building to hold onto that heat for that much longer. So in an uninsulated house, the heat goes straight out the windows, it goes straight out the walls, it goes straight out the roof and the floors. So in an insulated house, that heat is being trapped for much longer. So you're making use of every kilowatt of energy for much, much longer. It's a very low-tech solution to passive solar design, but it's a very effective way. So once you've put the insulation in, more or less, unless you're talking 50, 60 years down the track, the insulation is there for life. It's so important with insulation that you do the whole building. So a building, in simple terms, has 6 sides. It has the roof, the floor, and 4 elevations, 4 sides to it. You know, to get the maximum benefit with insulation, you do need to do the whole house. It's a little bit like wearing a jumper with a hole in it if you don't, because the energy can escape through the hole. So it's so important that the whole building is insulated, not just half of it. We measure the effectiveness of insulation with what's called the R value, and R is simply a factor of the transmission of energy from one side to the other. So the higher the R value, the more effective the insulation is. In Europe, they use the U value. Here in Australia, we use the R value, but anything from R4 to R6 is generally good. Generally, the higher the R value, the thicker the insulation is and the better the quality of that insulation. It's not terribly difficult to get insulation. Bunnings and all of those sorts of places has it. It's just a case of making sure that it's installed properly and then it's set and forget. Thermal mass, we talked a little bit about earlier. It's kind of hard in this context to explain it, but in simple terms, if you imagine a concrete slab on the ground in full sunlight, that sunlight heats the slab over time. So effectively, that slab becomes a battery. In simple terms, it's storing energy. And as the day winds down and we go into night, the energy from that slab, doesn't have to be a slab, it can be a brick wall, it can be another form of material that has mass to it, will re-radiate that heat into the evening. It can work in reverse. So on a particularly hot day, if you exclude the heat from that particular material, then that material, like a concrete slab, then that material will actually stay cool. And at night, that cooling effect has a bearing on the interior temperature. So it's kind of a bit of a science, the way that you use thermal mass. I'm a bigger fan for insulation, but those who know, certainly thermal mass is something that you should consider in the design of your buildings. It is particularly suited, I'm originally from a place called Mildura, which is a very hot, dry environment. It was a fantastic way to work in those sorts of environments because you had a big change between day and night. So very, very, very hot days and very cool nights. So when you have that big temperature differential, thermal mass works a treat. Where I live in, say, Thornbury in Melbourne, those temperature differentials are not as great, and I would argue there's not as effective. Now, those of you who are in the Shire will have your own knowledge as to whether it's effective for where you live or not. Can't say hand on heart that I would know. Glazing, I would just really reiterate something that's really, something that I think we've seen over the last 20 or 30 years is just the development of window design here in Australia. We've gone from cheap single glazed windows, poorly sealed, to really high standard of windows and glazing systems. And yes, they do cost more. I'm not going to lie, but the benefits are there for a lifetime. So getting the window design is really critical. Having too many windows is a big no-no. More or less in terms of the sort of surface area of your walls, you should be looking at about 25% of the area of the walls as windows, no more than that. A lot of architects will design, buildings with lots and lots of glass. I would discourage that, but equally we do want windows because we want that connection to inside and outside. And we want the ventilation. So getting the right quantity of windows is really critical when designing buildings for a resilient climate. The advances in double and triple glazed, U value, the window performance is measured as U. U is actually more or less the same as R. It's just the inverse of R. So generally speaking, the lower the U value, the better the window will perform. Okay. And there's probably two things to consider about a window design. One is how much solar heat gain it actually transmits. Okay, so that's called the solar heat gain coefficient. And the other is how well it can hold the warm air on the inside on a cool night. So it can do two things. It can exclude the heat by having the sort of glazing that reflects that heat, but it can also prevent heat loss by having double glazing and effectively having an insulation barrier between the inside and the outside. Ventilation. Well, ventilation can be your friend and it can also be your enemy. So if you've got a house that is, poorly sealed, there are gaps around the door, there are vents, there are downlights in the ceilings, there's air conditioners that are, got holes into the side of it, the ventilated skylights, chimneys, poor construction, so there are gaps in the floorboards and things like that. Well, all of that heat, doesn't matter how well your house is insulated, all those gaps are going to contribute to heat loss and heat gain. So ventilation in those circumstances could be argued as a good thing because you're getting fresh air, but it's a bad thing in relation to the heating and cooling. So ventilation is something you have to control when you're designing a building. So you want the ability to kind of control how much heat and cooling is coming in through your building. So if you have a well-sealed building, that's what you want to get to, but you also want the ability to be able to open up the building to let that ventilation in, particularly when you want fresh air and there's a cool change after a long, hot day. So control is really critical. And most older buildings are very poorly designed from an air tightness point of view. Condensation is, if any of you have been reading The Age, and generally speaking, there is a discussion going on about the fact that many apartment buildings are suffering from condensation problems, which can potentially lead to mold. And this is really dangerous in a house. So a house that is not naturally ventilated, a house where there is not good access to daylight, to sunlight, a house that's kind of small and pokey and not well connected to the natural environment is prone to condensation, and condensation is really a precursor to humidity and to potential mold. And that's really the biggest problem that we have in some contemporary houses, which can lead to really poor health outcomes for the occupants. So asthma, respiratory problems, and poor health outcomes. So we want to avoid condensation at all costs, and we want to create environments that are actually healthy for people to live in. Condensation, in really, really simple terms, is where you get hot, humid air. So when the temperature of the air is relatively warm, it has the ability to carry water in it. So it has a higher dew point. So it can carry more water with it. When that hot, moist air hits a cold surface, that water in the air condensates and falls onto the carpet or stays on the window or stays on the plasterboard, whatever it is. So it's essentially that differential that creates the condensation. That water is left trapped, and over time that can create huge problems for the people who are occupying the space. We talked a little bit about passive house versus passive solar design. Essentially, there's a lot of overlap, except that passive house is designed with a criteria in mind, and that is that there is a certain per square metre of space, there is a set amount of energy that can be used for that area. So it's up to the architect or the passive house designer to design a house that actually meets that criteria. So it sets a criteria that the designer has to meet in terms of energy use, in terms of air tightness, in terms of thermal bridging and other factors. And it's up to the architect to design to meet that criteria. By meeting that criteria, you get a passive house standard, and it generally means that the energy use of that building will be far lower than other types of buildings, other similar types of buildings. So it sets so it's a little less vague in the way that it goes about things, and sets a criteria and a standard that has to be measured and tested once the building is built, and through a whole series of calculations that occur during the design phase to ensure that you are actually meeting that standard. It, like passive house, emanated during the sort of oil crisis of the early 1970s, and it emanated from Germany, where the building physics of passive house was developed and fine-tuned. It's become very popular in Germany, Japan, parts of North America, England, and it's growing in popularity here in Australia. So it's confusing that we have two terms that are relatively similar. We've got passive solar design and passive house, and there is overlap, but they are two different standards. By and large, most architects, most interior designers, most designers in Australia are more familiar with passive solar design than they are passive house, but there is a growing popularity with passive house. Sorry, I did touch on this earlier, but it's about airtight construction, so really limiting the amount of ventilation that can come in and out of your building. And it usually has a heat recovery unit to compensate for that very tightly controlled ventilation system that's in the building. There are other things like thermal bridging and a very, very high standard for insulation that is also adopted for the building. Sorry, I'm repeating myself, but thermal bridging. So I'll just explain briefly what thermal bridging is. It's when you have an element that is connected between the inside and the outside, and that heat can transfer from one side to the other. Brad, did you have a question?
Yeah, I do, Anthony. I've been joined here actually by my wife, who's a carpenter, and has been enjoying the presentation. And she just had a couple of questions around I think it was permeable intelligent membrane. Is that like a breathable wrap, effectively? Is that what that's referring to, or is it something more sophisticated?
I won't claim to be an absolute expert, but it effectively allows moisture to travel through. You see it in jackets as well, so that the ability for materials to actually transfer moisture from one side to the other while keeping the air tightness in. So there's been ProClimber is a company that's been doing a lot of work in this area, and the sort of advances in that kind of technology has been really through the roof. So yeah.
And just one further thing on that, does both the wrap and the cladding need to be permeable, or can you kind of resolve that by battening out the cladding from the wall a little bit, so you've got a bit of an air gap there that the moisture can get out to? Or
it sort of depends on the situation. So battening is good. So generally speaking, on a typical wall construction, external wall construction, you have a weather wrap which goes on the inside of the cladding, just before the cladding. You then have your bulk insulation in the studs, and then ideally you should have a continuous layer on the inside. Then you have a permeable membrane on the inside, which can also allow for the transfer of moisture. But the outside layer, if I've understood your question correctly, is more about preventing moisture from entering into the building. So it is effectively the rain screen for the building. Where it sits in terms of the battening, I don't think matters terribly much, but it does matter on the inside face.
Yep. Okay. Thank you.
I'm happy to field any other questions, by the way. So I feel like I'm on a bit of a rant, but so hopefully I'm making a bit of sense.
It's going great, Anthony. We haven't got any questions in the Q&A, but Doug has flagged that if you do have any questions, feel free to put them in the Q&A, and I'll ask away.
Sure.
Thank you.
Well, the last part is really about retrofitting. So this is something I'm really passionate about. The idea that we retain existing buildings and retrofit existing buildings to perform better is a really good way for us to meet the sustainability challenges that we face. So, I'm all for retrofitting. Let's say a building has a 1-star rating, and we can raise it to a, say, 4-star rating, and we can do that, across, the suburbs of Melbourne, all the houses in the Shire of Bass Council. We can do a lot better by retrofitting existing buildings, whether it's council buildings, local scout halls, you name it. We can do a lot of good work. So essentially the idea of retrofitting is retaining the existing infrastructure as much as we can, whether it be walls, ceilings and so forth, and improving the performance of that building. It's as simple as that. We should never think of a building as, complete. The building gets designed, it gets built, and, new owners moved in. And much like a new car, you might get a year or two where you don't have to worry about changing the oil or doing anything, but all buildings, like cars, need maintenance. So understanding your own building, over time, gutters need cleaning, lights need switching over, and there is always just changes in technology and advances in knowledge. So, we should never think of our buildings as set and forget. We should always see it as something that you can evolve and change over time and adapt to meet the changing conditions of its location. Understanding your own behaviour. For instance, if you're living in a 6-7-star building, that doesn't mean, one of the common complaints is that people will still have long showers. People will still leave the air conditioning on for long periods of time. So even though, well-meaning occupants have this amazing building, their behaviour doesn't necessarily allow for that building to become energy efficient. So, much like a car, much like a bicycle, you kind of need to know the equipment that you've actually got, and you need to maintain that building for the life of that building. Buildings should be designed to last a minimum of 50 years. Ideally, they should last 100 years, but they do need that constant renewal if they're going to remain part of our future. If buildings are not maintained at a certain point, and again, the listeners will know, just visiting your local area, those buildings will reach a point where they have to be demolished. And that happens fairly quickly. 10 years of non-maintenance will, you'll find that buildings degrade pretty quickly. So you either have to do a major renovation, or that building has to be demolished. The principles of passive solar design are just as relevant to retrofitting as anything. So, because I think passive solar design is really understanding your building in relation to the environment in which it's located. So if you've got windows that are facing due west, that does not mean that the building is a bad building. It just means you need to cater for that set of circumstances. You can always improve a building's performance just by understanding how it responds to its local environment. So again, much like when you're designing a building, when you have an existing building, you just take the time to learn how it works and how it actually functions over the course of the year. Getting off gas, I think there's been a lot of talk in the mainstream press. The state government, although they're changing their position a little bit on this, but the trend is that we're going to move away from gas, and that gas prices in themselves are increasing. So it makes sense that we reduce our reliance on gas. Typically in a house, there are three things that are gas fueled. One is the cooktop, and now we have induction cooktops, which are really effective. Generally speaking, gas hot water that can be easily changed over for an electric system with a heat pump, which is generally speaking more efficient. And the third is a heating unit. Hydronic heating is a popular form of heating, but there are alternatives, and there is discussion in the near future that there will be a changeover product that will, take the gas hydronic unit and turn it into an electric unit. Landscaping, I think goes without say, I think has a really important part to play in creating a healthy, sustainable environment. Permeable surfaces so that water is actually being absorbed into the ground, rainwater gardens, plants that add shade and cooling, indigenous planting that encourages local wildlife or local flora and fauna to thrive around your building, I think makes really good sense. And buildings that are sensible in fire-related buildings. And this is where it gets a little bit scary, because when, we hit summer and we see bushfires, we see flooding, we see a whole range of things, it's kind of scary. And I'm no different to anyone who's watching this show, watching this webinar. Making buildings climate and disaster resilient is really critical, and we all have to play our own individual role to protect our own asset, but we also play a role in the broader community. We don't typically design buildings for resilience, for that climate impact. And it's sad that we have to do that. We generally design our buildings because we want family homes, we want places where we can live and thrive. But increasingly, we're thinking about what happens when there's a particularly hot summer and a particularly, cold winter or, heavy rainfall. We're in winter now, or we're in spring now, and we can't remember what it's like when, it's hot and there is, bushfires but they happen, and smoke and extreme events are just around the corner. As I say, particularly sad that we're sort of confronting this. It's always been a feature of our landscape, but it's the frequency with which these things are happening. So creating buildings that enable people to live in those spaces and prevent fire from taking a hold is something that we really need to think of. It is becoming an issue in relation to insurances. It's something that I would draw upon local expertise rather than me giving you advice here and now, other than to say that the Bell rating system that is out there is actually a very good system. So knowing the Bell rating of your particular area, whether it's Bell 19, Bell 35, and creating buildings that are responsive to those conditions are really critical. There is a lot of local knowledge in this area, particularly through the Fire Services Victoria, that I would really tap into if we're talking about fire resilience. Preventing ember attack, just simple, my understanding of this area of expertise is that simple decisions can make a big difference. I also know that how quickly fires can ravage a house and a community. So those critical moments when a fire is upon you are really critical. Human life is much more important than, our building assets. So, I would also encourage anyone who's listening to prioritise their own health and safety in these extreme events. It is just around the corner. Summer is just around the corner. We don't know what that means. Each year is a little bit different, but we do know that the events of bushfires is becoming more frequent. I don't think there's anyone who could argue that. So these are the Bell ratings. So Bell is bushfire attack level. Any new house has to respond to the Bell rating of their particular area. Choosing a site, I would strongly encourage not to go to Bell flame zone, because, you know, it's almost impossible to prevent bushfires in those sorts of environments, and to be looking at Bell rating areas where there are Bell ratings 12.5 and 19 as, you know, reasonable opportunities to create houses that are bushfire resilient. We are seeing more floods in where I live in Thornbury, in inner city Melbourne. There's a lot more focus now on floods, and just being aware of that is really critical and what you're going to do. Floods might seem like it's not that invasive, but having seen what floods can do to a house is quite dramatic, because it's coming in at that low level. It virtually impacts everything that you own and value. It comes in at the furniture level. It can erode, destroy carpets, doors. So how we design buildings to be flood resistant is really critical. Look, I feel like I've gone on a bit, but these are some of the buildings that we've designed, which I would argue are climate resilient and, connected to the built environment. I would really encourage people who are listening to this webinar to know that there are lots of times in the year where it's actually really good weather, and really where we can create connection between inside and outside. Spring, autumn, even large parts of summer and winter. We have really blessed to have a really beautiful environment here in Victoria, and creating buildings that are responsive to that environment means that you're going to create a kind of house that's connected to nature. So while we're talking about some of these more extreme events, it's also important to recognise that the majority of the time we actually have really good weather, and creating buildings that are connected to the environment is a healthy and positive thing to do. We just need to be mindful of those extremes and create buildings that help us adapt to those extreme events. This is just a really lovely view of the garden, where, which has been featured on Gardening Australia recently, which is really good. And just how the interior works with blinds, simple things, blinds and sun shading have a massive impact. Oops. I think that's it for me. There are plenty of resources. When you get involved in sustainability and sustainable design, I would argue that people are very generous with their time and knowledge. It's important to verify information that you get, particularly from suppliers, materials. There's a lot of new products out there. But I think, generally speaking, people who are working and operating in this sort of field are very generous with their knowledge, but also just, take a critical view to anything that you're being told, but also just use first principles, knowing your own location, your own site, the way the weather works. They're the things that you can really respond to when you're designing your building to be climate responsive and resilient in sort of the face of a changing climate. I'll hand it back to you, Brad.
Thanks so much for your presentation, Anthony. That was excellent. So much knowledge there. It was greatly appreciated. Just on you mentioned, I think Doug put a link in the chat to portable induction cooktops available that so people can actually try them out. We actually have some available down here to be borrowed from our local library. So you can go along to any of the Miley libraries in South Gippsland, Bass Coast, and loan a induction cooktop if it's something you're not familiar with. We recently did some renovations to our house and have got off gas and switched to induction. And at first, I must admit, I was a little bit skeptical, having enjoyed cooking with gas for many years, but absolutely love it now. And so, yeah, if anyone's out there is thinking about it, by all means, go out and try out the lone induction cooktops that we have available. And we also have other energy efficiency kits available from the libraries that have, you can do a basic energy audit, has instructions how to do energy assessment on your home, and thermal imaging cameras as well. So you can look for weak spots in your insulation and so forth with those, and they're all available to be loaned from the Miley libraries. We've got a few minutes left for people. If anyone wants to ask any further questions, we don't have any in the Q&A just yet that I can see, but if there's any out there, please, now's the time to pop them into the Q&A and draw on Anthony's immense knowledge while we have him here. I've got one that I can fire away while we wait. You spoke about the importance of orientation, which I think most people could appreciate. Do you have any tips for retrofitting a house or renovating a home that has poor orientation?
So I would take the view there's no such thing as poor orientation. So you can always make and that might sound a bit glib, but there are, you've sort of got a 1 in 4 chance that you've got a perfect orientation depending on where your block is, right? Because where the front door is in relation to the street and so on and so forth. So, there are, clerestory windows, skylights, nothing is sort of governed in an existing building. So you can reorganize the building to suit the conditions that you've got. And there's nothing wrong with, let's say you've got a living room that's facing due west, as I was saying earlier. That it is completely plausible and possible to make that western living room work to your favor, because in 9 months of the year, having a western aspect is actually quite pleasant. But it's just in 3 months of the year, it can be not so great. So as long as you're kind of aware of the conditions, you can make it work for you. So I would say with retrofitting, there are some buildings that don't, do reach an end of life, and maybe an extremely poorly oriented building, poorly constructed building falls into that category. So I would also say that.
Great, thank you. We don't seem to have any more chats, so questions in the Q&A. So, sorry, there has been one that's popped in there. Thank you. Where are we? Okay, what would you consider when trying to balance using gardens and vegetation for shading and amenity versus managing bushfire risk from having fuel close to the house?
Yeah, it's a really good question. It's part of the problem that we're sort of facing now, isn't it? Because we're living in these more extreme environments, there's greater risk. We are having to lose the benefit of gardens close to buildings. So there is no easy answer to that other than to, you don't actually want gardens really close to your building in a bushfire-prone setting. That's the honest truth of it. And if you do, you're getting the benefit of that garden, but you're running the risk. So I don't have an easy answer for that question, because that's a conundrum. But it's a conundrum that we've sort of made for ourselves, unfortunately. So, look, I do take the view, if I was to sort of hedge my bets a little bit, I take the view that, we're here on this planet not for a long time. And I'd like to see, our buildings thrive. And, so I'd rather see a garden and, connected to my house and enjoy that. And to some extent, I would take the risk. But it's just something you've got to be so mindful of when you're doing that sort of stuff.
Thank you. And one more question just around the preventing condensation and the tension or the potential tension between air tightness and condensation, and how you deal with that without maybe going as far as mechanical, ventilation and heat transfer sort of systems. Is it really a matter of being able to open the house up a little just occasionally, or is there certain things that you can design in that sort of does that for you?
Yeah, the principles of sort of passive solar design, I think, prevent condensation. I think small footprint living is really essential. Access to daylight, access to sunlight, and the ability to open up the building in a fashion is really critical. You just don't want to, just think of a dark wardrobe, that you've never opened. That's and it gets a little bit of water in there. That's kind of the perfect precursor to mold happening. If that wardrobe is sitting in daylight, can be opened occasionally, can be ventilated easily, then that mold is less likely to grow. So it just comes down to a bit of a common sense approach in terms of how you manage it. You don't need mechanical systems. No, you don't need that at all. But I would suggest that it's the ability of not creating those environments where mold and condensation, are left unchecked by ventilation, sunlight. They're the primary things that can prevent that from happening, and getting that cross ventilation occurring is really critical. So I hope I've answered that question. So for instance, if you've got a really large house with lots of rooms, big roof, 2-story, a McMansion, shall we call it? Then there'll be places within that environment where condensation will happily live. If you've got a small little hut, let's say, taking the two extremes, small little cottage that's, timber clad, lots of windows, all that sort. It's unlikely that mold and condensation is going to find its way in that house because it just doesn't have the opportunity to find it.
All right, thanks very much to everyone for your time tonight. I hope this event was informative and helped answer some of your questions and you may have had about how to retrofit, renovate and design your home to be more resilient. And can I also extend a special thank you to our expert presenter tonight, Anthony Demarse, for lending us his expertise and experience for the evening. Thanks heaps also to Doug from Renew for his behind-the-scenes support. Before we close the evening tonight, I'd like to remind you that the next webinar in our Sustainable Living series around sustainable building materials will be at the same time next week, Wednesday, the 18th of September from 6 to 7:30 p.m. You can register for this webinar and others on the CAP website that we mentioned earlier, and there'll be a link in the chat. That's all for tonight. Thanks heaps for your attendance, and I hope to see you again next week. Bye.